Never had a microphone before. New experience. Okay, so tonight I wanted to talk about process innovation. It's a little bit of a trip down memory lane, really, and I really wanted to kind of remind everybody a little bit with a story from from my past, really, just all about the journey that we've gone on through through the whole IT industry over the last 20 years or something, has come about through us practitioners. It didn't. The whole Agile movement really didn't come about from the Project Management Institute or the Prince 2 people. It was consultants and practitioners on the ground that brought a grassroots change to the industry. It was something that was absolutely fundamental to me, just remind everybody that it's really important that Agile isn't done yet. We're on a journey to keep on improving, and it's really important to keep looking outside the IT sector for inspiration. So it's a bit of a call to action, just to keep innovating in our space, and to just reflect regularly on what's going on in the teams. How many have you run experiments recently? What have you tried? What have you thrown away? What have you adopted? So just a really little bit about me. So my name's Roy Brayshay, by the way, just for any of those that don't know me. I run an IT consultancy business based in Leeds. We do things that IT consultancies do, provide expertise and teams. But I'm something of an IT journeyman, really. Here I am back in the early 80s with an IBM tape under my arm. And the other thing you'll know about me is that I've been involved in running this group, which is something of a passion project of mine. We've been involved in it since around about 2011. We've had hundreds of speakers. We've run hundreds of events now, shot hundreds of videos. Andy's done those mostly. There are thousands of people in this community. So, and we've just been nominated for a facilitation award as part of the Leeds Digital Festival. So pat yourselves all on the back. Okay, so my story is, process innovation is a little bit of a dry space. So it's kind of wrapped up in a little story, and it's all about a bit of insight that I gained in a gig that I did, consulting gig, probably 10 years ago now, at Formula One constructors team down in Enstone in Oxfordshire. It's the Alpine team now, but at the time it was the Lotus team, just about to change into the Renault team. And, it was a super interesting time for me, really. So the story starts with this. Anybody know NCAP, what they do? Anybody heard of them? Well, there's some nodding heads. Yes? So hopefully a video will play. So NCAP, yeah, it's the body that really they crash test, an independent organisation that crash tests mostly family cars and provide the star rating that sort of most people are familiar with now. It started in around about 1997, I think, was when they first started. And we take it for granted now that family cars, it's easy for us to know which are the safest and which are the less safe, but it hasn't been around forever. Now then, you're probably asking what's the connection with Formula One? So does anybody know who this guy is? Beg your pardon? Max Mosley. Max Mosley, yes. Fantastic. I thought I was going to have to give you some clues, really. So obviously, the son of a slightly divisive politician. But here he is as a very young racing driver with goggles around his neck. He later went on to become an owner of the March team, but really the connection and the story is that he went on to become president of the FIA, and together with its kind of, I wouldn't say a sidekick, but a collaborator, Bernie Ecclestone, who was the founder of FOCA, which is a constructors association. Between the two of them, they kind of had the F1 scene, I wouldn't say sewn up, but they certainly they had control of it between the two of them. And Max was a businessman himself, and it was quite clear to him that there was a commercial opportunity, as well as it obviously being great sport and spectacle in itself. But it had a little bit of a dark side. Does anybody any idea what the dark side of Formula One maybe used to be? Beg your pardon? It's Nazi stuff. I know, he was famous for several things, including a very long-running libel case with I think the Daily Mail, maybe? Yeah? Formula One, back in the early days, back in the 50s, it had a real bad problem with fatalities. And obviously, that did, it affect its attractiveness for TV, attractiveness for sponsors, and it was obviously not a great situation for drivers either. I think, in the 50s, 15 drivers died, carried on through the 60s, 14, 13 in the 70s. But in the 80s, it dropped significantly to 4, and we're going to talk, a little bit about why. And that carried on dropping 2 in the 90s, and I think there's only been 1 so far in the 2000s. So absolutely fantastic news for drivers. What brought about that big step change in the 80s? Oh, you guessed it, crash testing. So the connection with the NCAP organisation was that Max Mosley had experienced the profound change that crash testing had brought about in the F1 industry, and he actually became kind of one of the early. I think he was maybe the first president for the NCAP association, but he was definitely a huge supporter and was one of the major influences for its success. Obviously, it wasn't just crash testing that made that huge step change in Formula One. There's a huge advances in materials technology and carbon fibre, and a whole plethora of other safety features that were brought in. But this was one of the significant things. So, crash testing was absolutely fantastic for drivers, but not so great for teams. It caused teams all sorts of problems. And to sort of understand why it caused teams such a lot of problems, it's probably necessary to think a little bit about the nature of Formula One, the kind of industry it is, and how a modern sort of Formula One team operates. So, historically, Formula One teams did all sorts of things, but nowadays they operate more as a package. So, every team typically has some kind of engine partner, some kind of deal with a engine manufacturer, and the engine comes shrink wrapped from the factory. They obviously work with the manufacturer, but they typically don't do too much development work themselves. The tyres, which used to be a huge part of the equation, all the teams have the same tyres now. The FIA organise the tyre supply for the team, so that's a variable that is a constant across all the teams. Things like suspension geometry is kind of a known quantity now. The motor racing industry, or the motor racing has been, we've had 120 years or something of motor racing now. It's reached its, it's a solved problem, reached its kind of natural pinnacle of evolution, if you like. Everybody knows kind of, how to build suspension. Nowadays, the battleground is aerodynamics. And every team now is packed to the gills with dozens and dozens of very highly qualified, very well paid, very experienced aerodynamicists of all kinds. A lot of them come straight from the aeronautical sphere, but that's typically their background. Adrian Newey. People familiar with Adrian Newey? He's currently the lead designer for Red Bull, but he's pretty much, he's been several teams before. Probably one of the most successful car designers in the industry. I think 7.9 million or something is sort of saw his salary recently. But Adrian Newey isn't alone. There are loads. All the teams have an Adrian Newey. There are dozens and dozens of other designers working really hard. And while Formula One is a motor race for the drivers, for the designers, it's a design race, or for the engineers, let's say, it's a design race. And that's one of the reasons why this is all, was actually my time down at Enstone was so interesting, is because it turns out that while a Formula One factory looks like a kind of manufacturer, there are raw materials coming in one end and car parts coming out the other. They're not a mass manufacturer. They only build 3 cars a year, 3 or 4 cars a year. Let's say when they build a part, they build 3 of them or 5 of them or 6 of them, single figures. What slows them down is the design work, which is very similar to software. In a software team, the equivalent of, let's say, manufacturing, you might say that kind of the operations part, deployment part is kind of like that. But it's a very small part of the cost of the whole process. The majority of it is design work. So lots of the things that are going on in Formula One teams are, remarkably similar to what's going on in software teams. And the pace of development is relentless. Between each race, if the team don't make gains, they don't find ways to make the car go faster, absolutely goes backwards on the grid. So the pace of development with all the teams is relentless. And we as kind of agilists, we like our retrospectives. We like to be able to look back and see what's gone well and try new things. Celebrate our gains. We like our PDCA cycles. But Formula One teams occupy a kind of special space, because not only do they need to try and find gains between each Grand Prix during the season, but the effectiveness of the whole organisation is getting tested live on TV in front of 80 million people, and that has a profound, that's a profound signal. And if the car hadn't performed at the weekend, absolutely you could feel it on Monday morning in the factory across, everybody. So and the other thing I wanted to mention at this stage is, we've talked about aerodynamics being one of the kind of the battleground. These guys, they talk about aero points constantly. Aero points being their kind of measure of aerodynamic gain, in very similarly to our own familiar kind of story point stuff. It's a completely arbitrary figure. It's a mixture of, reduction in drag, increases in ground in downforce. There are many things that go into that, but all the teams know they need to find 10 or 12 or 15 aero points between each Grand Prix, or they start to go backwards. And they look back and they use that arbitrary measure to measure the whole design team's effectiveness, just exactly like we might look at our past performance to try and predict our future performance. So they're constantly trying to find ways to all these designers, all these aerodynamicists that are in the teams, they literally have hundreds of ideas a week, and it's impossible for them to implement all those ideas. So all their efforts and all their energy and huge amounts of money are invested in all kinds of simulation, modeling, finding, fast prototyping, ways that they can throw the ideas away as soon as possible. Yeah. So I'm going to get back to my story a little bit more now. So this isn't AI great. This is the Red Bull Christmas card. So the problem with all the crash testing came about because typically things have changed a little bit now because I think the Formula 1 season is longer, but traditionally the last Grand Prix of the season would be in August. I think it used to be Adelaide or the Australian Grand Prix, and then the teams had between August and Christmas to design the new car. And they would work really very hard to do so. They would all go home for Christmas, have a week break with their family, come back in the new year. And the first thing that they would do in the new year is submit their car for FIA crash testing. It used to happen at Cranfield. I think it maybe still does, I don't know. Which was great, but if it failed crash testing, that was a huge problem. They would have to go back to the factory, look at the problems, redesign, iterate on their ideas, remanufacture many of the parts, remanufacture the chassis of the car, and then find a time when they could get back for a retest. And typically, they might lose weeks. They might even lose the whole of January. And this is bearing in mind that the first Grand Prix of the season usually is in early March. So between Christmas and March, they need every inch of, or every minute of design time they possibly can get. So the cost of delay here was enormous and really grave. So, what did they do? Does anybody know who this guy is? James Allison. Somebody say James Allison? Yeah. So James Allison, he's the race director, I think, now for the Mercedes team, but at the time he was the race director at the Enstone team at Renault. So, and this kind of bit of insight is something I stood in an all-hands meeting when I was there. It gathered the whole factory, 650 people into a room to talk about the problem that this exact problem that they'd had last year. They'd lost a month's development time after Christmas, and basically it had ruined their season. They'd kind of never ever been able to recover from that, and they spent a long time trying to grapple with what they could do. So he had a plan. And it was like his rally cry, really, to try and to galvanise everybody into action. So this is what he did. This top kind of bit of Gantt chart shows what used to happen. So the last Grand Prix of the season is somewhere here. This is the design of the new car. This is Christmas. They come back in the new year. FIA crash testing. If they fail, it's rework, and all that lost time. FIA crash testing again here, and they've just lost half their development time ready for the first Grand Prix. So instead, there was this hugely expensive, and the reason that it was a bit of a rally cry was because it was so expensive. They decided to form 3 teams, 3 fast flow, super nimble teams, independently building 3 different cars. So 3 times the resources, 3 times the tooling, 3 times the use of all the facilities. It was a really difficult thing to pull off, but had huge benefits. So the first team were the kind of the bleeding edge, the bleeding edge crazy guy team, building a car as light as it could possibly be, stretching the rules as far as they could be stretched. And they kind of almost expected this car to fail. But if it did fail, they were like, woof, look at that. We're gonna have the lightest car on the grid. The second car, the second team, this was the kind of let's say kind of the target car. That was the car that they were expecting is gonna pass. But they were still trying to sail quite close to the wind. And they were confident in sailing that car that close to the wind because they had a third car up their sleeve, the kind of the backstop that was that they knew was conservatively designed, and it was something that was, you know, almost certainly going to pass. So hugely expensive, but the benefit was this avoidance of the cost of failure. So leaving themselves a predictable amount of time to be able to keep development going until the start of the year. But of course, it also had a side effect that they could more confidently design a car to the absolute as close as they dare to the rules. So at the time, this was kind of thought was being a little bit crazy. I mean, I don't know what used to go on in other Formula One teams, but this was, you know, it was quite difficult to kind of get this past or you know, get backing for this kind of thing. However, nowadays, I think it's sort of become common practice. So this is a quote from Helmut Marko, who's the current Red Bull design director. You know, teams now are almost expecting the first design that they submit to fail, and you know, this kind of practice is the norm. If we had passed the first crash test, that would have been precisely the problem. I think this was a quote either last season or the season before with the Red Bull design. It had been rumoured that it had failed crash testing, and kind of journalists were kind of probing for thinking that there were problems at Red Bull. And this is him rebutting that as, no, it's absolutely exactly what we wanted to happen. So you know, that kind of innovation is I mean, it's not, you know, rocket science to kind of do that kind of stuff. It's not about technology. It's completely about just kind of rethinking the problem, reframing the problem, and thinking what the possibilities could be. Many of these kind of innovations are about, you know, trying to shift time. You know, I think the number plate is out of time on the Back to the Future car. Typically, in our world, very similarly, you know, they're about either shifting time or trying to reduce transaction cost around some of the, some of the sort of rote tasks we might do. So we're obviously investing in things like CI/CD pipelines, which reduce the transaction cost of deployment and allow smaller batches of work. Similarly, with automated testing, things like stakeholder demos that we're all fond of, and focus groups, UX testing, we're all about trying to get feedback sooner and quicker. F1 teams invest enormous amounts of money in collecting data. Terabytes of data, telemetry data come off a car during practice, as well as, you know, my time there, we spent building lots of trackside data collection tools that would be fitted to the car, fitted to the suspension, did all sorts of other kind of ambient data collection. All that kind of data is fed directly back into the simulators, back into the models that the teams use, and nowadays, those models and those simulators are all, you know, they're kind of some of the most valuable IP that the teams have, and treated like the crown jewels. And in fact, you know, it's if you kind of read about, you know, some of the things that, in the press that go on in the teams, they're often talking about this season, because of rule changes and because of the changes to the car, we're a little bit out of step with our simulator, and that's just causing us problems. It's making us making us less competitive because we can't iterate fast enough. We're losing the design race effectively. So the other thing I want to mention, who knows what's going on at the moment? What's this? Does anybody know what this is? America's Cup. Yes, America's Cup. Does anybody know about the America's Cup? It's like Formula One on water. So the Ineos Britannia, Ben Ainsley's team, they're partnered with the Mercedes Formula One team. The unique thing about the America's Cup is the rules are rewritten every time it's run. It's the oldest sporting cup in the world, I think 120 years old or something. The UK, Great Britain held the cup once when it was the very first year it ran in 18 something or other, and have never won it back since. Emirates, Team New Zealand are the current holders. But these boats are, a huge step change. So 75 feet long, 6.5 tons, sailing at 95 or 90 kilometers an hour in 25 kilometers an hour wind. And interestingly, or kind of importantly, not only are they a huge technological step change, and I should say, the foils that they're sailing on are, kind of more loaded than a MiG fighter or something. But the sailors on board also have a problem because while these boats have there are some traditional roles. There's still a helmsman, there's still somebody holding the steering wheel, there's still sail trimmers. Now they have a flight controller. So traditionally, America's Cup had been populated with, top flight sailers that have honed their craft over kind of decades. Nowadays, there's four what they call cyclors, so people from other sporting disciplines, typically cycling or rowing, that are generating the hydraulic power that they need to drive the thing. But the sailors themselves, interestingly, have a problem just in upskilling because these boats have only just been built over the last 2 years. So modelling a simulation is hugely important to these guys as well. This is the kind of social media photograph of the sailors, back at the Ineos base on the simulator, practicing their art, trying to work out what it is they need to do to make the car go faster. There's a kind of flip side of the camera, which is kind of the less social media friendly side, a bit more comical. But that's the reality, and these guys, all these teams are spending weeks and weeks and weeks in this way now. So that was kind of a little story about, simulation, process innovation. I wanted to just rattle through a little bit of process innovation that kind of, started outside our industry that we've brought in, and try and just remind everybody the kinds of things that we have adopted. This is, maybe we can just kind of, shout out. So just in time, people familiar with just in time? It's used in manufacturing everywhere for, just manufacturing parts just in time. The retail industry uses just in time from a delivery perspective. Does anybody know where we use just in time in software development, or the kinds of things that we adopt the same approach for? Things like collecting requirements, the whole purpose, the whole using user stories as a placeholder for conversation in order to delay collecting requirements to the last reasonable moment. Do anybody know what Zara are famous for? Beg your pardon? Women's clothing, they are. Fast fashion, though, is a huge, that's kind of one of the things that they're known for. So instead of, building or creating huge numbers of garments for a whole season's worth, nowadays it's about making small batches, getting them in shops really quickly, seeing what sells and seeing what doesn't sell. So obviously they make more of what sells and less of what don't sell, and keep iterating in a very similar way to all of us in the software industry. This Dell, what this Dell represent, I don't know anybody. This is kind of quite a long time ago now. The Dell kind of represented, or they kind of pioneered the whole build to order. We take it for granted now that when you order a PC, you pick what memory you want, what processor you want. It was pretty radical back in the 80s. And that's again something we're all, teams always talk about, if you ain't going to need it, don't build it, Yagni and things like that. Toyota production system, Toyota factories. Obviously, there's an absolute ton of stuff that have come out of this. Does anybody ever look at the Toyota website? and there's a huge amount of kind of lean manufacturing guidance on there. Clearly we use things like Kanban and Kaizen, but there's a ton of other stuff. This one, the and-on chord. So I kind of wanted to kind of call this out a little bit and include this slide. The and-on chord is a simple kind of thing, a bit like how I try not to break the build, maybe, I don't know, but nowadays, one of the things that I always think about, and I think is super interesting, is in order to make an and-on chord work, it isn't just about getting a bit of string and tying it from the roof and stopping the line. I think it's important to think about the work that the leadership team and the management team have had to do to get the right level of safety. For anybody to actually be able to pull that cord. So huge amount safe, huge amount of work to get that, to make that work. I really like, so this is, what's this? McDonald's kitchen. So I love the kind of McDonald's kitchen just because there is no technology in a McDonald's kitchen, is it? It's fridges and fryers. But the innovation is about how it's all put together, how how the kitchen's designed, how the packaging fits, how the things are integrated, how it's integrated with the order system. There's a ton of stuff there. And the other interesting thing, the other thing I love to see when I don't go in at McDonald's very often, but every few months I do. I think it's always a bit different. They march forward relentlessly. Often not big changes, but it never stands still. I just changed this slide. I've only got a couple of slides left. Steve's. Yes, Oasis. Has anybody got an idea why this slide's here? Dynamic pricing, yeah. So everyone's in huge shock, aren't they, at the Oasis gig, dynamic pricing. Obviously, Amazon have been doing dynamic pricing for 20 years or something, haven't they? Everybody buys flight tickets. There's, it's kind of inevitable, and I'm sure it's going to be inevitable that there will be more dynamic pricing going on. It's just waiting for people to innovate and adopt that. And then I've got this last slide here. Does anybody know where this is? Spaghetti Junction? Yeah, it is. Birmingham. So people familiar with the whole digital twin kind of movement? It's kind of like the simulator stuff that happens in Formula One. Building digital twins to help kind of model what might be the outcome of change. So lots of cities now have they've got a digital twin project. I'm showing this Birmingham one because it's this picture of Birmingham because Birmingham had one quite a long time, and it's quite advanced, or they've been at it for a long time. But the idea is to help urban planning, basically help them iterate to be a better city faster by modelling the city in all sorts of ways. And then lastly, this is my little micro innovation. So I've been talking today about does anybody use Confluence whiteboards? No! So I was never a great fan of Confluence, but I've kind of been a bit of a convert really with Confluence whiteboards. Confluence whiteboards, we use it for retrospectives now. This is a bit of fun. Somebody in our team, Chad, with a whiteboard that looks like a rugby pitch. But the super cool little innovation is you can right-click any of the tickets in it, any of the sticky notes in it, immediately turn it into a Jira ticket. So, boom! In kind of one action, you've kind of got a trackable, measurable improvement system. Give it a go. I think it works really well. And that's really me done. So I'm kind of over to you. I just want to kind of remind you all that Agile isn't done yet. To keep looking outside our industry, keep looking for opportunities to change the process, run experiments, keep iterating. or eventually we will become irrelevant. Thank you very much.